Hello, this is Tober's class, lessons. Tober's class lessons, chapter 5-6. This is lesson number 2. Lesson number 2. The force vector. The direction of a force makes a big difference in what the force does. That means the force is a vector like velocity, which means it has a direction, which means it can be positive or negative. The arrows are often used to show direction of force in our physics diagrams. Here's an example. In this example, we've got two guys pushing, and what I'd like you to note in this particular example is that this guy is pushing with 10 newtons, but which direction is he facing? He's pushing to the east. East is a positive direction. This guy here is pushing to the west. West, as a force vector, is a negative. So we use the arrow to point in the direction of the force. Also in these guys here, you got to also understand is that not just the length of it will tell you the size or the magnitude, but if this arrow was big and thick like this, that would also indicate the magnitude of it too. So sometimes we can simply measure for a distance, in this particular case, 5 centimeters, and we could say that's 5 newtons. Or we can notice that the thickness of the line itself is telling us that it's a very strong line. It's a comparison to that single line there. One-way forces act as a result of direct contact. A contact force is transmitted by matter by touching directly one another, such as the wind. The wind here is touching the parachute, causing the parachutist to slow down. The cool stuff is what we call action at a distance. Action at a distance is known as a force field. Force fields can be things like gravity, or if you've ever played with a magnet and used a magnet to push another magnet away or attract another magnet, that would be a force field or action at a distance. Here are some ones that we need to classify. The two individuals here are playing tug of rope. They're playing tug of rope, and that means they're actually touching the rope itself. This is a contact force. Touching the button is a contact force. The wind touching the air, touching the parachute, is also a contact force. This here would be a force field. Gravity is known as a force field. Ropes and springs are often used to make and apply forces. Ropes are used to transfer forces or change their direction. The pulling force carried by a rope is called tension. Tension always acts along the direction of the rope. Here's an example with two guys that are pulling on a rope. You need to note that the tension is only 100. It is not the combination of forces. Tension along the rope is only 100. Force can be created by a spring is proportional to the ratio of the extended or compressed length divided by the resting length. So it has to do with distance. So the distance of the force. Springs basically change the distance that is applied of the force, which changes the time of the force that's being applied. Stretching it out is extension, compressing it is compression, or pushing it together is compression. Gravity. The force of gravity on an object is called weight. The Earth's surface, gravity exerts 9.8 newtons for every kilogram of mass. You need to know. You need to know this conversion, that 1 kilogram is equal to 9.8 newtons. So if something is 1 kilogram, it's 9.8 newtons. And like the acceleration due to gravity, if you double the acceleration due to gravity, you get 19.6. If you triple it, you get 29.4. or that would be known as 3 kilograms. Weight and mass are not the same, as you already know. Mass is the fundamental property. It's measured in kilograms. It's also going to be our base unit when we are talking about mass. And the force of gravity on the Earth, of course, is 9.8 newtons per kilogram. Weight is a force. It's measured in Newton. Weight depends on mass and gravity. In this example here is just the same example where if you have something that's 10 kilograms or 98 newtons on the Earth, it'll still be 10 kilograms on the Moon. However, the weight will have changed because it weighs a little bit less, which means the force of gravity on the Moon is less. You need to know that weight is equal to mass times acceleration due to gravity. Please write this down. Weight is equal to mass times acceleration due to gravity. The other thing that you need to note is the weight in our problem is going to be in newtons. Our mass is going to be in kilograms. And acceleration due to gravity on the planet Earth is 9.8 Newton meters. Here's how you solve a problem. Dividing a given 9.8 is acceleration due to gravity. So you can figure out how much he weighs by dividing 9.8. This is the end of lesson 2.